Hi everyone and welcome to this episode of Keipert Labs. In today's episode we're going to talk about the respiratory system. So we're going to have a little overview of what the respiratory system is, and then we're going to go through each of the parts. We're going to start with the nasal cavity, we're going to look at the trachea, to the bronchi, the lungs, the alveoli, and then lastly the diaphragm. Each of these playing an integral role in being able to make sure that you can get oxygen into your body and can get carbon dioxide out. So the respiratory system, its job is gas exchange, we say. It facilitates or allows oxygen to get into your body, which is something that your cells need for respiration, and that carbon dioxide, which is the waste product from respiration, that can leave your body. So oxygen in, carbon dioxide out, both of which are gases. So we call this gas exchange because they're swapping places in this process. So you can see some of the main kind of features. We've got our nasal cavity and our mouth and nose that take air in. It passes down through our trachea and our larynx and down the bronchi into our lungs, which is where that gas exchange takes place. All of this process happens as a result of what the diaphragm is doing to be able to cause air to come into your body and then to leave your body. All encased inside your rib cage to keep it protected and safe. So we're going to go through most of the aspects of what we see here to see how each one contributes to the respiratory system. So firstly, let's have a look at the nasal cavity. So that is this area inside your nose. Now, yes, you can breathe through your mouth, but your nose in particular is designed for you to breathe in and out, or in particular. When you're a child, the idea is that you actually only ever breathe through your nose. So, when babies are feeding, that it's important that their nose is unobstructed because they don't know how to breathe out in and out through their mouth. So breathing in through the nose helps to draw air into the body. Okay, so this is kind of what it looks like in a cross section. You don't see any of this, and you're probably not even aware that it exists. But the idea is that so you have your nostril over here, that the idea is that the air makes its way through your nostrils down the back of your throat. Okay, so firstly we get a layer of filtering that happens here. The nose hairs are designed to filter out any dust particles or solid particles that shouldn't make their way into your lungs. We also have a layer of mucus that you particularly notice when you're sick that's designed to trap these particles and to allow you to expel them from your body. So nose hairs provide this filtering, but then also the other jobs of the nasal cavity is designed to make the air moist and warm. So that is that you want the air to have a high amount of moisture and also to be at the same temperature as the rest of your body, and it does that through the blood that flows through these kind of bony parts here called the concha. And so the idea is that the air flows over and past them, that there's very significant amounts of blood flow through there that then helps to warm up that air and allow it before it passes down through there. The reason that you want it warm is that otherwise your body's got to expend energy to have that air warmed up further down in your system, and it means that you're actually wasting energy. You're not getting as much out of it. And it passes through your nose, it's filtered and cleaned, and it makes its way down through your trachea, which is also more commonly known as your windpipe. Okay, your trachea and your esophagus running kind of parallel to one another inside your neck and throat and down into your lungs. It's got this kind of upside down Y sort of shape. It has the larynx at the top, which is your voice box. The larynx is it's part of this system, but it's not actually. It's just designed to allow you to make sounds. But yeah, so the trachea is how the air gets transported down into the lungs. It's protected by really tough cartilage around the outside that's designed to stop it from getting easily crushed or squashed, because obviously that would cut off your air supply. This is kind of what it gets damaged when someone is being strangled or kind of these sorts of things to actually designed to kill someone. This cartilage is designed to protect against that. Inside the trachea, you've got some different protection mechanisms. Firstly, you've got mucus, which is designed to kill and trap bacteria or dust or anything that may have passed through the nose unobstructed. It gets caught in this mucus, and then you cough it up, or that it comes out of your body. A part of that system also is these things over here called cilia, which are basically really fine hair-like things that line the inside of your trachea that are designed to help. They basically vibrate to move the mucus up and out of your trachea. I know it's probably not a great image to be thinking of, but the idea is that it's very important to keep you healthy. If it doesn't work, you get a buildup of mucus inside your lungs, and you get things like pneumonia, and which can kill you. Okay, so it's important that your body has a way to help clean itself out, to protect itself, to keep it nice and functional. Okay, so the air makes its way down through the trachea into what we call the bronchi, which is the plural of bronchus. You have two, but they're basically branches. One goes into one lung, the other goes into the other lung. That then from each bronchus, that then it kind of branches off into what we call bronchioles, which are narrower, kind of smaller tubes that lead their way all the way down to these little things that look like bunches of grapes called alveoli. We're going to talk about them in a second. Okay, but so the idea is that it's basically we're going smaller and smaller little pathways down to each area of the lungs. So let's focus on the lungs. This is kind of the tissue that basically is designed for gas exchange. We're going to look at these little alveoli in a minute, but so you've got two lungs that are designed to be able to take in and process the amount of air that you need to. They have a fixed capacity that you generally only replace a very small amount of the air in your lungs at any given breath. But the idea is that you can, by taking deep breaths and by forcing a significant amount of breath out, cause more or less air to be swapped out of your lungs. Okay, your lungs have different lobes as far as kind of little sections of them that then kind of work there. That you've got a bit of a difference there in the size of your lungs. You can't really see it in this image, but the left lung is actually slightly smaller than the right lung in order to accommodate the space for the heart, which kind of is situated in the middle here. Okay, so it's a little bit, so the one on your left is a little bit smaller in order to make room for the heart in the middle. Okay, that the lungs contain these alveoli, which is the places where gas exchange takes place. Now, part of the reason that you have two lungs is to process enough air. You also it means you can survive with only one lung. Obviously, your quality of life is going to be very different because you really can't take a lot of deep breaths. You can't really do a lot of exercise that requires a lot of breath in and out in a short time. But it means that you can survive if you have to. So now we focus on the alveoli, which is really arguably the most important part here, where the gas exchange actually takes place. So oxygen goes into the blood and carbon dioxide comes out. So we get deoxygenated blood, so blood that doesn't have enough oxygen in it, that comes from the heart through these tiny little blood vessels called capillaries. They make their way past these little spherical shapes and it picks up oxygen and makes its way back towards the heart. Freshly topped up with oxygen, ready for distribution. You can see a little bit more of a close-up of how it works here. So the capillaries with the red blood cells come down through here, that oxygen diffuses from the alveolus into the blood, carbon dioxide diffuses out of the blood and into that same space. Okay, and so we're swapping those gases, oxygen into the blood, carbon dioxide out. Continually doing this swapping over process as we breathe in and then as we breathe out, to take in more oxygen and release carbon dioxide. Okay, that they have a little kind of layer of what's called surfactant in order to help them make sure that they don't shrink, that they stay like this bubble spherical shape. It stops them from collapsing under themselves. Okay, and we have this capillary network surrounding them so that you get maximum kind of gas exchange. You can swap as much as possible in a short time. That's partly why you only need to replace a little bit of breath in a normal kind of resting environment. You only swap out some air at a time because it's very efficient at doing this gas exchange. The whole reason it works is due to the muscle we call the diaphragm. So the diaphragm is a muscle that extends from one side of your body across to the other, kind of comes directly underneath the bottom of your rib cage. So you can see it's kind of the green line that's represented here. Now, the whole reason that you're able to breathe in and out is because that diaphragm, which separates the chest and the abdominal cavities from each other, it's kind of like a layer, a barrier, it is able to contract and relax. What that does is it changes the size of the chest cavity, the thoracic cavity, which is where your lungs are. Okay, as that cavity gets bigger, the pressure inside your lungs is lower than the air around you, and so air gets pushed into your lungs. Okay, that the gas exchange can happen, and then the diaphragm then contracts, and so then it pushes, and it increases the pressure inside your chest, so then it's higher inside your chest than out, so it pushes that air back out. And then the process repeats over and over again you know, every second or so, you know, 60-something times in a minute for normal kind of slow breath. So that this idea of that without the diaphragm doing this, that then you can't breathe. Okay, so someone who is winded as often has that experience where the nerve that helps to control the diaphragm has been disrupted, and so then you're actually, you might be thinking about breathing, but you can't easily take that control back. Normally you do, you know, breathing is one of those functions that happens automatically, but you can exert some control over it. You can choose to take a deep breath, you can choose to hold your breath, you can choose the speed at which you breathe in and out to some degree. But your body has a lot of automatic control over that, so you don't have to constantly think about breathing, because that would be exhausting, you can imagine. Okay, but so what you're able to do then is you're able to exert some control over what this diaphragm is doing inside your body. So being able to cause that breath in and out. So we talked about the respiratory system, facilitating gas exchange, oxygen into your body, carbon dioxide out. We looked at then the different parts, the nasal cavity to help filter and warm and moisten the air as it comes in, the trachea to be able to transport it towards the lungs with some protection mechanisms to trap nasties, bronchi to be able to kind of send it, the air into each lung. We have 2 lungs to do where this processing happens, significant amount of tissue. The tissue contains alveoli, which is where this gas exchange actually happens, and the diaphragm is the whole reason that you breathe in the first place. Thanks very much for watching. Don't forget to like and subscribe. Bye for now.